Good afternoon. Welcome to European Entrepreneurship and Innovation at Stanford Engineering. This is the final session 8 of the 2016 speaker series here at Stanford. Today is March 7, 2016. And our topic for the day is From Comets to Startups, Building Europe's Space Tech Entrepreneurship Ecosystem. So our speakers today come from the European Space Agency, Frank Salzgeber, who is Head of Technology Transfer in Noordwijk at ESA, who is here with 3 of his companies from the ESA Business Incubator System, one from the UK, one from Netherlands, and one from Germany, 2 hardware, 1 software company for a little bit of diversity. And so ESA is known for doing great space science, space exploration. What is less known is what the European Space Agency, and specifically the Technology Transfer Office, has been doing over the past several years to build a pan-European space tech startup ecosystem, including startups, incubators, venture capital, angel groups. It's a very interesting story, which is not very well known here in the United States. European Space Agency Technology Transfer Office is our 2016 partner. We're very grateful to you for your support. Our first speaker will be Frank Salzgeber, Head of Tech Transfer for the European Space Agency. I've known Frank for over 8 years. I think first when he invited me to speak at the second Space Investment Summit when I was representing Space Angels Network. Frank, it's a delight to have you back in Silicon Valley and here at Stanford. Thank you very much.
Thank you, Burton. It's a pleasure to be here, and we worked hard to show a little bit what we do. And for the first slide, I'm not a space engineer. I'm an industrial engineer. I worked for Apple. I had my own startup company, and by default, I got an invitation to work with astronauts. I was not married, had no kids, and said, that's pretty cool, let's do that. Later, I figured out that I ended up in a very administrative agency with different rules to the market. I'm still there because it's a wonderful place, because we're working with wonderful people. Under the slide, you see a lot of flags. And this is one thing which may make the space agency in Europe so different. We have 22 member states plus Canada as associated. So they're working together with different national agencies and partners is in our genes. Everything what we do is built on cooperation. And when we look into ESA, our heart is in Europe, but we are spread across the world. We have a budget of roughly 5.4 billion every year, where 85% goes to industry. So companies like Airbus, OHB, and Thales working for us, and they develop the hardware which is flying to space later. And the headquarters in Paris, but really the heart of engineering is in the Netherlands. It's ESTEC, it's the technology center where you see it's right behind the shore. And my small team is in the small barracks, so we always call ourselves the aliens of ESA, because we're not only looking to space, we're recycling everything. It is a waste of brain power if you take an innovation for only one purpose. So we believe that the technology and the knowledge we develop, we can reuse, recycle, and repurpose in many fields. Therefore, it's not just about rocket science. You see this picture and that combination not at the same time, that you see on the one side the Ariane 5 rocket and the Soyuz rocket. I know Arianespace would love that they would be launching as often like this, but we are not there yet. And when we look into the European Space Agencies, we're one of the few agencies which nearly cover all the fields of space. And here, this is the next capability to go to Mars, which we launch on the 14th of March. ExoMars, it's in the test center there. So the scientific part of our agency is the core, where every member state are participating. And of course, we're also doing telecommunication, connecting people, ground segments. We're helping our industry to build telecommunication satellites. This is Artemis satellite, which is in the big vacuum chamber for the tests. Galileo, Europe has asked us to build the European navigation system. It's building infrastructure like we did in telecommunication. And this is a project which we're also looking forward to fight with technology. Space debris is a problem. We're polluting our orbit, especially the lower Earth orbit. So we're working on robotic missions, how to eliminate the space debris. And this is an endeavor I think all mankind has together, because when we continue polluting the low orbit, we eliminate our future. One of the project of our Director General is the Moon Village, which is our vision in Europe, what to do next. And I always take the example of the gold rush. When we're looking to America, it would not have happened if we would not have villages in the desert taking care of the supply of wood, of maybe whiskey. This you will not get, of course, on the moon, but with oxygen, power, and so on. And therefore, I think this is something as endeavor we can do jointly in the world to develop a moon village as a further vision. We're participating in the International Space Station. Mr. Gerst looking down to Earth. And looking down to Earth, this is also done by our Earth observation satellite. It's the Copernicus office. It's a fleet of satellites measuring the health of our Earth. And this helps also to change the view. This is a camp, 3 square kilometers in size, hosting 100,000 people, 10 kilometers away from the Syrian border in north of Jordania. Big data and Earth observation also helps us taking care of managing crisis, helping to understand Earth. So it's not only about data, it's really a tool which is used every day. When we're looking to the science missions, what we said Rosetta, and these are only 3 transfers we have got out of Rosetta last year. One is detecting bugs where you don't want to have it. One is cleaning the air in a submarine, and the other one was special parts in harsh environments. And the same is also for our rocket program. When we're looking to the Ariane, we always see how we can develop and use this technology, recycle and repurpose it in a different means. And this is in the aviation industry, like our software, which is in our control center. Our Houston is in Darmstadt, so where we're running our mission operations. And this is used for crisis management. This is used for aviation. When I started 10 years ago, coming from industry, coming from human spaceflight, we started with 5 brokers, looking to the IPRs of our industry. We had 1 small incubation center supporting 8 companies. And this is one of the advantages working for an international agency. You have time, more than a quarter to develop things. And when we're looking now 10 years later, I know it's a little bit a bust now, so we're taking care of the entire patent portfolio of ESA ourselves, licensing off. We have a network of brokers in 14 member states, asking the space industry what they work and what they develop, and asking the non-space industry what keeps the R&D manager awake in the night. We're running hackathons, we're running prizes, we have 1,500 new ideas what you can do with space technology. We're running at the moment 16 incubation centers, supporting over 130 new startups every year. We have a track record of 400 startups, and this is growing. We also started 8 years ago a limited partnership to a venture capital fund, which was a quiet endeavor, because this is an engagement which is not normal for ESA. And we embedded that with networks of Tectrons networks, business angel networks, VC networks, even family offices with the right research centers. It can only grow when you have the right eco-environment. We have a nice saying in Austria, when you go fishing, you have to be taking care that the worm is tasty for the fish, not for the fisher. Sometimes in governmental organization, we forget that. So the focus is on industry, the focus is on startups. And this was becoming, over the last years, so successful that we're covering entire Europe nearly, and it's copied already by CERN, by Fraunhofer and Airbus, and all the big national agencies are working in this network. It's so successful that we go already abroad. We have the first requests from South America, South Africa, Arabia, Asia, and we hope also that this network goes across, built on collaboration. Before I close, I want to make a little snapshot in space. This is space now. If you need a satellite, you go on the web and buy it on the web shop. It's one of our startup companies. It's about components. This is the current market. And this is sometimes, I say, the space industry. It's like the Addams family. They're pretty cool, but for the outside, they're freaks. And this is what we have to overcome. Because when we go back in life science, evolution is not brutal, evolution is direct. Either you die out or you go the route of evolution. There's nothing in between. Some people think there is a between, but it's not. And it's good if people dying out or spaces, because it makes room for new spaces, and nature is filling that immediately. All what I've done in the last years, I've not done alone. And I've done it with a team which has the size of a startup company, which are 50% female, 50% guys, left-brainers, right-brainers, lawyers, business development, market people, engineers. It's the right mixture. It's like the mixed pickles party, which is the best party, where you know 10 people and 50 you don't. And I close with one picture, and we stay with Mars. In summer 2003, Mars Express, not ExoMars, was leaving Earth on the way to Mars. And on the way to Mars, Mars Express turned 90 degrees back to Earth. And normally the pictures we know are from the Apollo program looking down to Earth or looking up to Moon. This view is not familiar. But 90 degrees sometimes is enough. On the one side, you have Earth. On the one side, you have Moon. And this is the space you need to get your business off the ground. Thank you very much.
Great. Questions?
30 seconds left. Okay, that's good.
Yes. Sorry, did we have a question here in the middle?
And no nasty questions. That's good.
Okay. So, yes. Hi, Duygu.
So my name is Duygu. So technology transfer is already hard, but it's in the space domain. It's I think harder. So what I wonder is that a demand initiated technology transfer, or I mean, you are saying, hey, we need this, and can you make this, or you are trying?
You mean upstream?
Yeah. Is it that
I give you an example, and it's a very easy one. It's one of our engineers is one of the specialists of solar trackers, so that the solar cells are always in the perfect angle on the sun. And he said, if you buy the sensor, it's about 16,000 euros on the normal market. And he's really one of the few engineers which I would say is world leading. And he said, okay, I want to produce this in mass production for the downstream market, for solar concentrators on Earth. So he gets into the mass production, he sells it for 350 euros to the normal Earth market. And out of the mass production, he said, well, it would be a pretty good idea to bring it back to space, because I have zero production. So he did that, and he sells now for 3,500 euros to the space market. So they cut the production cost into a quarter. He's still not successful, because for the space industry, this is a 3-people company, 3 years old. So when you come to the evaluation criteria, background and experience, which we are really don't like risk in space, yeah, whoop. However, we have a new trend. He received, I think 3 months ago, a letter that he's preferred supplier of OneWeb constellation, because he's cheap. So therefore, spin-in or spin-off or technology transfer is not a one-way street. Yeah? You bring it out in the market, and you buy it back when you need it. And I think this is what we have to learn. It's not a one-way street, and there are enough crazy ideas around. You only have to help them to bring that back. And if money is the pressure, even better. Was that the answer?
Yeah.
No. Next question. So
I saw that.
Oh, yes, Richard.
Yes. Could you tell us, I understand that Galileo, the GPS project, has 17 more launches or thereabouts. Does ESA go to market and get bids to determine who the launchers are? And have you gone to SpaceX, Elon Musk's company?
What a nice, interesting question. You have to see, this is a project of the European Commission. They have asked ESA, as a kind of architect, to do this. Yes. So our possibility to influence is limited. So this would be a question to the European Commission.
So just to clarify, the European Commission is a completely separate entity from the European Space Agency.
Correct.
Okay.
So Norway and Switzerland are member states, and several European Union member states are not member states of ESA.
But ESA and the European Commission have a cooperation agreement?
Correct.
Right.
So we have 2 big projects. One is Galileo, and one is Copernicus. So I always say the Commission is an administrative agency. We are a technology agency. Because we know the technology, we don't take the cheapest proposal, we take the best proposal. I don't know what my colleagues in the Commission do, but I think we do it different.
Yes, Eric.
Do you have policy constraints from ESA, like geographic return?
We have. That means what a member state pays in, they get it out. It's geographical return. And this is the reason why industry really likes us. However, we are not restricted to deal with other member states. There we have several possibilities, including our IPR. Maybe not for North Korea, but if you say Singapore or South Africa, so it's very easy to deal with them and do cooperations. We are a junior partner on the ISS, and it has advantages and disadvantages. But when you're looking to our member states, everything what we do is cooperation. And I believe that in the cooperation with a multinational team, it has, especially when you have complex system, advantages. Because everybody's approaching a problem differently. And what you want to have is the best output. But we have geographic return.
Okay. Frank, thank you very much.